Last year, I visited Garner, Iowa to tour Stellar Industries. On that trip, Tim Worman gave me a full tour of a T-Max mechanics truck, which included Stellar's HPS, or hybrid power source. More recently, Tim walked me through the updates and capabilities of the HPS in detail.
Good morning, I'm Tim Worman with Stellar Industries. I'm the Director of Product Management and Inside Sales for the company. And what I'd like to talk to you today here at ConExpo 2026 is our new hybrid power source. Now, our HPS was introduced in 2020, but we've done some revamping to it to be more modular. What we're really trying to accomplish here is the ability to run a mechanics truck on a job site 100% emission free. That doesn't mean the truck is 100% emission free. What we're trying to do is provide a solution that allows the prime mover to get you to the job site, allows you to work all day, and then get home at the end of the day. We're employing a thought process of carbon neutrality, meaning that I can use a traditional ICE chassis to get me to the job site, work for 8 hours, and then get me home. So let's say I drive 2 hours to the job site, work for 8, drive for 2 hours back. I basically banked 4 hours of zero emission. So really moving towards that neutrality of carbon footprint. Reason being that's so important is traditional EV chassis that are out there, we haven't found one that you can mount a mechanics truck to. The batteries are outside the frame rail. They're heavy, they're long, they're really meant for other markets other than a mechanics truck. So we looked at it and said, how can we provide a solution? The HPS is a lithium-ion battery pack that drives an electric motor with a hydraulic pump on it, allowing us to run a hydraulic crane, a hydraulic air compressor, just like you would with a PTO and pump, only with the truck turned off completely at the job site. This gains a lot of things. You have all the efficiency of normal operation from a PTO and pump without any idle time. And you have no noise. So let's say I'm on a job site in a city and you have a lot of noise reverberation off of buildings. You don't have that with this truck because your truck isn't running. It's very quiet and you just hear, the crane motors moving, things of that nature. The energy pack itself is a 13.5 kilowatt hour, 48 volt. And why is that important? At 50 volts, you have to be placarded for high voltage. You have to be placarded for high voltage. At 48 volts, you don't have to have that. You still have to be cognizant of safety issues and things like that in the event of an emergency. But think about a field mechanic. He doesn't deal with high voltage every day. A lineman, yes. Field mechanic, no. So if the truck is placarded high voltage, he gets a little bit nervous. And so we wanted to stay underneath that threshold. With a 13.5 kilowatt hour, 48 volt, depending on duty cycle, depending on what the operator's doing with it, full charge will last probably 4 to 8 hours. Again, based on duty cycle of what the job is happening. So let's say it runs out at 4 hours. You're still on the job site. I still have 4 hours to get work done. I can charge this system off the truck chassis itself. So I turn the truck back on, let it run, and let it charge my system back up. I can still do work at that point because I'm going to charge faster than I'm going to consume. So the truck can charge it up within about an hour or so. You'll have a full charge back, shut the truck off, keep working. The other option you have is, let's say on a job site you have a generator, which most job sites will. You can plug the unit into that shore power and charge it that way also. And that way you can keep working, especially if you don't want the truck to run. Right now the output of it is about 12 gallons a minute, 3,000 PSI, which is perfect for running our 40P air compressor, which is a staple of the industry, and any one of our telescopic cranes. It is agnostic as far as what chassis it ties to. It doesn't care what chassis. For the charging, we just hook up to the alternator system and it charges the system up. So it doesn't care what model chassis it sits on. It really gives some flexibility for operators that are cognizant about wanting to improve their carbon footprint without having the drawbacks of a traditional EV chassis. And we've designed it so it can be scalable for the future, put a larger electric motor in it, drive more pump, a higher flow pump, higher pressure, Everything has to be balanced based on what the hydraulic horsepower draw is to the electrical draw. Over to electric and just only do electric, or I can do electric and hydraulic to be able to run the cranes. So depending on what I'm doing at the job site, I can go either direction with that.